Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 8E. Myself, Ishita Sauran, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Goa, India, and the virtual event is being held through Zoom from the 17th to 19th of July 2025. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session. We have with us Dr. Satish S. Banath, who is currently working as Associate Professor, CSC Artificial Intelligence, VIT, Pune, India. He has published 34 research papers in various journals and 17 papers in various national and international conferences. He is a reviewer of reputed national and international journals. His area of interest includes data mining, artificial intelligence, machine learning, big data, IoT, and software engineering. We welcome you, sir. We'll be starting with our papers. I'd like to
Thank you, Sita.
thank you, sir. We'll proceed with our paper presentations. The first presenter, Manasi Gulesar, with the paper titled Anviksha, a machine learning model for passive bot detection. Ma'am, if you're ready, then you may start with your presentation.
Hello.
Yes, ma'am.
Audible?
Yes, ma'am, you're audible.
Yes, I'll just share the screen. Is my screen visible?
Ma'am, not yet.
Hello, is it visible now?
Yes, ma'am, it is visible.
Yes. Okay, so good afternoon, everyone. My name is Manasi Goresar, and I'm from Nasik. So my paper title is Anviksha, a machine learning model for passive bot detection. This work is a collaborative effort with my co-authors and my guide. So basically, we all interact with web applications daily, like shopping, banking, healthcare, social media, etc. But there's alarming rise of bots and automated systems. So as of 2025, over 3.5 million websites worldwide rely on capture technologies to differentiate bots and humans, with Google's reCAPTCHA alone being used for over 100 million times daily. So this project seeks to just eliminate the captcha and replace or give a passive solution which will collect environmental data through the browser using machine learning. So basic objectives are to capture the environmental parameters, develop a passive detection system which will passively collect the data and analyze it with our ML model, minimize the user interaction, and integrate it with existing systems. The software requirements and hardware requirements for our projects are basically for our paper, I have used Flask as my Python framework for basically all the model formation and all, with the use of TensorFlow. And the algorithm which I have used is random forest. So this is our system architecture, where the user will interact with the computer with the help of a registration form. And from the backend, the data will be collected through the API gateway, and this API gateway will then send all the collected data through to the machine learning model, which is where we are using random forest. This model will analyze the features collected. Now, the features collected are the mouse movements, the keystrokes, the locations, and various other behavioral metrics. And from those metrics, we will analyze whether the user who is interacting with the website, whether he is a human or a bot. And if the detected user is a human, he will proceed with the verification and he can interact with the system. But if it's detected as a bot, then he will not be able to access the website. So the behavioral matrix which we are collecting are device information like the screen dimensions, uh, then mouse behavior, the mouse speed and patterns to help indicate the human versus scripted bot. Then we have typing, clicking, form fill speeds, which we are collecting. Then we have duration times, session times, which are being collected. Then also the OS, what he is using, the IP address, and etc. These all behavioral metrics which are being collected, these are collected through JavaScript mouse event handlers. So there are basic functions which are used to collect these metrics. The algorithm here, this is the algorithm for our model. So here we are first fetching the data which is being stored in the database. So the data from there is being fetched, it is being processed, cleaned, and analyzed. Then now the random forest will extract random features, like random sampling will be done. And uh, here we can see that the n estimator equals to 100. That means 100 decision trees are being generated, and these 100 decision trees randomly uh, randomly classifies the like randomly analyzes the features. So and they will generate the answer, that is whether it's a human or a bot. And through the majority vote, the like if like from 100 trees, if 90 trees are being detecting that the user is a human, so through majority vote, human will be our final answer. So this is the basic, this is our front end. So from here, this is a basic form. Now, wherever we go, like in any website, so the first thing we have to do is we need to fill a form. Now, whenever we fill a form, we have captchas there. So these captchas are basically a defense system. So instead of using captcha, our main work is we have to eliminate the captchas, because the captchas are very frustrating, and the bots or automated system nowadays have become so much smarter that they can crack the captchas. So our main motive is to eliminate the captchas, and whatever decision has to be taken, that is done passively. Means the user should interact minimally with the system. So here, like, you can just fill the form, and whenever we click on the register, now if it's detected as human, we will go to the next page, like the profile. And this is our dashboard. So we had analyzed over more than 20,000 samples, and our current accuracy is like approximately 100%. And we have used XGBoost and as well as random forest. So basically the features are being trained on both the models, and whichever is giving higher accuracy, the accuracy is being shown. These are our graphs. So as we can see, the multiple behavioral patterns like mouse speed, click frequency, typing speed, session duration, and idle time is being shown. The red color shows that it's a bot profile. So as we can see, the mouse speed is more. That means the bots are basically faster than humans. So uh, like mouse speed, we have click frequency, we have typing speed. So we are comparing the times of the humans and bots. This is session matrix. This shows the time for which the session is being attended by the bots and the humans. And this is a the very important feature, that is the typing speed. Now, as we know that the bots are very much smarter, they can sometimes they think that they can also pretend to you like pretend to type slowly so that they might not get detected. And also, they are very fast. So we can see the human time also, that the range of the typing speed of human is constant, like it is between 0.2 to 0.7. But bots can pretend to type slowly also, and also they can be faster. So this is being shown, like how the bots and humans type. And if there is a bot detected, he will be shown to the error page. So he will not be able to break through the system or move forward with the application. So this is our accuracy. More like the accuracy for our random forest was like 0.999. And for detection of bots, so for detection of bots or uh, like uh, to pretend like how bot will this like how he will um, what we say how he will use the system, we had used scripts. So there were cyber scripts which we used, and when we run the scripts, so it shows how bots uh, interact with the system. And from those scripts, when we run those scripts, the form is filled automatically, like how the bots fill. And this is basically to avoid DDoS attacks also. And for future work, we might involve developing the APIs which allow bot detection module to easily integrate with other various applications for creating plugins, middlewares, etc. We can also use, instead of random forest, we can also switch with the CNN networks so that the model will more efficiently perform. Then we can also expand the system's capability with different web platforms, providing more flexible deployment options, because nowadays the web apps are being made on different various platforms. And the limitation is that the machine learning model may not generalize well across all web environments. So for those web environments, we need to develop more APIs. And here, we need to do regular retraining of the model so that the model will be more efficiently and accurately be able to differentiate or classify between a bot and a human. And we have ensured that we have ensured our privacy via using canvas fingerprinting. It is nothing but it generates unique identifiers without collecting any personal information. And we ensure that there is no personal identification is being collected. Data is anonymized and also encrypted as we store it in the AWS. And also we are using a honeypot field. This honeypot field is invisible to the users, but it catches the bots effectively. So in conclusion, we basically Anvixa offers a robust and a user-friendly, privacy-preserving solution to bot detection without using any friction of traditional captchas. Thank you for your attention.
Okay, my question is that why NLP used in chatbots?
Hello?
Are you hearing me?
Yes, sir. Yes, sir. By NLP what?
Why NLP used in chatbots?
Yes, so basically natural language processing is used in chatbots to understand, extract the language or understand the text. So basically when we when we give any prompt to the chatbot. So basically, chatbot has to understand what is the prompt, and he needs to extract the keywords, and then he need to find from various resources that what answer he needs to give. So basically, for extraction, analyzation, and understanding, chatbots need NLP.
Okay, thank you.
Okay, thank you, sir.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to call upon Devash Damodran with the paper title Decoding User Sentiment Towards AI-Powered Fitness Applicants, Sentiment Analysis of User Reviews. Sir, if you're ready, then you may start with the presentation.
Please, please.
Yeah. Sir Devash.
Hello?
Yes, sir. Yes, sir.
Hello?
Yes, you are audible.
Hello?
Yes, sir, you're audible.
Yeah, so can you see my screen?
Yes, sir.
Yeah, okay. So, good afternoon, everyone. So, I am here to present my paper Decoding User Sentiment Towards AI-Powered Fitness Applications, a sentiment analysis of user reviews, ICT4SD 2025 conference. My co-authors are Krishna Bharati and Dr. Danyayam. So, this is the background of the study. So, here we can see India is currently facing a dual health challenge, like under new communicable diseases like obesity and diabetics. So here, this is from India Index 2023. So it's mentioned that uh, like overweight and obesity affects over 23% of adults in India. Also, meanwhile, an estimated 75 million adults in India are affected by diabetics. So there is a growing interest in digital health tools. So, post-pandemic shift also, we can see a shift towards the fitness applications. So, the pandemic further accelerated this trend. People become more to track calories, workouts, and their routines. This is a fitness app market report. It was the fitness app market size was 16 billion in 2023, and it is forecasted to grow around 76 billion USD in 2032. So, here, we reviewed several studies that emphasize how sentiment analysis can help app developers improve users and satisfaction. We build on existing research that highlights the importance of usability, effectiveness, and personalization in user satisfaction. So prior work has focused heavily on technical features, but emotional engagement and ease of use are equally important. So we identified a gap that few studies have analyzed how users' trust, expectations, and feedback patterns influence long-term usage of AI-based fitness applications. So here, by achieving these goals, we hope to bridge the gap between user experience and app development. So our primary objective is to analyze user sentiments toward AI-powered fitness applications and identify key drivers of satisfaction and dissatisfaction. And we had secondary objectives like to identify the recurring themes in user feedback and also to identify a classification and to develop a classification model. Here we have used logistic regression and SEM. So the methodology is we collected over 5,000 reviews from Google Play Store across like 10 popular fitness-based apps between 2022 and 2020 to 2024. And we have used Python tools like Beautiful Soup and these steps like tokenization, normalization, and stop word removal. Then we applied NLP and machine learning to analyze both the text structure and the emotional tone. Here we used, like I mentioned earlier, like logistic regression and support vector machine. This analysis and interpretation. So uh, uh, here out of over 5,100 reviews, around 62 percentage were positive and 38 percentage were negative. That is, and even for app developers, this hello.
Yes, Dev, please continue.
Yeah, okay. Um, so here this is the positive word cloud that we generated. So we can leverage these to further enhance the user engagement and satisfaction. This is the negative word cloud. Here on negative side, the common words include want, disappoint, don't, paid, etc. like that. So these are the key drivers of satisfaction. So we analyze the positive reviews like effectiveness in achieving fitness goals. Here I have also provided some reviews given by the users as an example. Here effectiveness like app help users from habits, lose weight or track calories. In user experience and ease of use, the clean UI and features like community support were well received. In personalization and adaptability, many users have appreciated tailored routines and recommendation. In positive reinforcement and motivation, like positive feedback mechanism like progress tracking help users stay engaged. This is the key drivers of dissatisfaction. So first point how cost and value perception. Many users felt premium plans were overpriced or that useful features were hidden behind the paywalls. In unmet expectations, users were disappointed by the updates, glitches, or the changes to the interface. In usability, technical issues, in inflexible routines, and bugs made it hard for users to stick with in lack of engagement and support, like lack of customer support or useful community features led to the drop off. And this is September model. Like people choose to reject how useful and easy they perceive it to be. And this power of positive sentiment where when users feel they are and perceived is like poor UI or technical issues frustrate users. We developed the logistic regression. It had high precision for positive reviews, meaning it was good at predicting positive correctly. However, the recall was very low. It missed many actual positive reviews. Overall, the accuracy was 69%, which leaves room for improvement. In support vector machine, it had more balanced precision and recall across both positive and negative sentiments. The higher F1 score shows that SVM is better at handling real-world sentiment complexity. This makes XVM more suitable for automating the review analysis. The practical implications from a development perspective, first, enhancing personalization using AI more effectively to tailor suggestions. Second, improving designs and minimizing the technical errors. Third, offering transparent and flexible pricing to better match user expectations. And finally, ensuring that customer support is responsive and empathetic. These steps can significantly improve the user retention. In future scope, we could scale the work using larger data sets, include more diverse platforms like iOS reviews, and also we can break down sentiment by individual apps to see what users like or dislike about specific brands. Also, we can add a time series layer to analyze the changes in sentiment over time. Also, combining reviews with survey data to reduce bias and validate the findings. So, thank you.
There was my question is how you can calculate the sentiment.
Hello, hello.
Hello. How you can calculate the sentiment?
Like, sir, we use the machine learning models to find the sentiments like positive and negative.
And can we use CNN for sentiment analysis?
Which ones are CNN?
CNN. Yeah.
Yeah, I think yes, sir.
Okay. Thank you.
Okay, sir. Thank you.
Thank you, sir. We'll be proceeding on with our next paper presenter. I'd like to call upon Shilpa Raj with the paper titled Driving Business Sustainability Through Social Media, Exploring Digital Women Entrepreneurial Ventures. Ma'am, if you're ready, then you may start with your presentation. Ma'am Shilpa?
Yes,
Yeah.
I hope my screen is visible.
Yes, ma'am, it is visible.
Yes, so I'm Shilpa Rajar. I'm working with Amrita Ahead Online BV program, and I will be doing my PhD under the guidance of Durga Lakshmi CV. So this is a public paper that we are preparing as part of my research work. So the topic is driving business sustainability through social media, exploring digital women entrepreneurial ventures. So coming to the introduction, the digital technology and social networking platform has transformed the business by enabling wider reach to customers. Just a minute. I hope my screen is visible, right?
Yeah. Continue.
Yeah, okay. So the digital technology and social networking platform, which has transformed business globally by enabling wider reach, customer communication, and sustainable practice. So the social media, which provides a unique platform for women-led enterprises, particularly those in developing states like Kerala, to overcome the traditional constraints like limited access to market, lack of financial resources, and business connection. So the existing research is focused basically on the challenges, business sustainability, and women empowerment. But there is few studies are there to explore the convergence in the context of Kerala. So there are women entrepreneurs, they are believed to be the key drivers of advancing the sustainable development goals as per the United Nations studies and their research. And there are efforts to promote equal opportunities for all the races and all the genders. So the financial independence and creative thinking and environmental sustainability is also a sustainable factors to be explored. So, however, this role of digital platforms on promoting the entrepreneurial sustainability among these women-led firms remain understudied. So this research is particularly focusing towards the questions: how does the social media influence idea generation, customer connectivity, collaborations, and sustainable practices among women entrepreneurs in Kerala? So this study has basically the four objectives. The first is to examine the use of social media for idea generation among women entrepreneurs in Kerala. Next is to identify the extent of social media usage for customer connectivity and collaboration among women entrepreneurs. Third is to assess the sustainable practices adopted with the support of digital platform and to identify the relation between social networking channels and sustainable business outcome. So when it comes to the literatures, so the woman benefits greater flexibility, freedom, empowerment, and independence and autonomy as a result of their presence in social media platforms. And it is also providing different opportunities, and it is also a platform for acquiring new skills. And also, when it comes to social media, this is providing the entrepreneurs are able to observe what should be the problems and what are the solutions for the multiple perspective. So additionally, which is also providing as a platform for accessible marketing entrances due to the increased visibility, and it's also an innovative practices. And when it comes to the innovation is one of the important factors that drive the entrepreneurial ventures. When it comes to social media entrepreneurship, it is also considered to be one of the factors which can drive their long-term sustainability. Okay, so next is coming to the methodology part. So this particular research is basically a descriptive research design, and we have administered a stratified random sampling method here. And the target group of this particular study is women entrepreneurs. Why we choose the women entrepreneurs? Because they are right now basically in the case of a medium and a small scale business entrepreneurs, the women entrepreneurs, they are especially focusing on the social medias in order to promote their product, in order to advertise their product, and to make the awareness of their product. And the data collection, for the data collection, we have administered the structured questionnaire, and the 100 samples were collected across Kerala. So this was the demographic profiles that most of the respondents, which comes to the age category of 30 to 39, and when it comes to they are dealing with the different types of business activities. The most of the respondents belongs to the category of retail business activities. And the first hypothesis that we have tested for the study is the social media usage significantly influenced the frequency of idea generation among women entrepreneurs in Kerala. For this, we have administered the chi-square test, and the result shows that there is a significant relationship between the social media usage and the frequency of idea generation. And the active social media use, which is enhancing the ability of women entrepreneurs in Kerala to generate innovative ideas for their business activities. So the second and third hypothesis, which is about the customers and stakeholders collaboration and the adoption of sustainable business practices. For that, we have administered the Pearson correlation, and the results which indicate that social media usage shows a significant positive correlation with both customer collaboration and adoption of sustainable business practices, which is also confirming the validity of this hypothesis. And when it comes to the fourth hypothesis, which is related to the significant relation between the use of social media and the sustainable business practices outcome. So this is the results. So which shows that the results strongly support the hypothesis is demonstrating the social media usage, which plays a crucial role in fostering the sustainable business practices among the women entrepreneurs in Kerala, and business is leveraging the digital platforms are more likely to integrate their sustainability into their operations, and also transforming the potentials of social media in entrepreneurship. So coming to the conclusion, the women entrepreneurs and social media usage have a positive impact on idea generation, collaboration, and sustainability in women-led ventures. So this study results align with the existing literature, which is emphasizing on transformative role of social media in entrepreneurial context. And the social media platform which enables women entrepreneurs to easily interact with the customers, network with other business, and to communicate their eco-friendly practices to the global audiences. So, yes, sir. Any questions?
Yeah. So my question is that what is the relationship between the social media engagement and customer loyalty for women-led business?
Customer loyalty and
The relationship between social media engagement and customer loyalty for women-led business.
yes, sir. So when it comes to the woman-led business, the main objective of the study is to identify how this women entrepreneurs are using social media for their entrepreneurial ventures. So when it comes to social media, the major indicators are the first is the customer interactions, their stakeholders in interactions with like the supplier or their ventures interactions. That is why considered the customer interaction as an indicator for evaluating or for measuring their impact on the social media activity.
Last question is which major challenge faced by woman entrepreneur? Major
What is
challenge faced. What is
yes?
the which major challenge faced by the woman entrepreneur?
What is the major challenge that is faced in the social media platform, right, sir?
Yeah.
Yeah. So when it comes to social media platform, the first important thing is that the technological know-how. That is what it is considered to be the very, because when it comes to a business entrepreneurial activity, it is very important that they have to be up to date with the technological advancements. So this is one of the major constraints because most of the women are they are having or they are leading a family. So that sometimes they may not get enough time to getting the training with this kind of activity. So through my research, I have found out that the major difficulty is that to cope up with the new changes which is happening in the technological background.
Good. Thank you.
Thank you, sir. So shall I proceed?
Yeah, sure.
Yeah, so the recommendation of my study is the first is to the government initiatives. They should implement the training programs for the women entrepreneurs to use of social media to promote the sustainability and business growth. And next is about to provide the literacy initiatives and to build infrastructure to support this kind of women entrepreneurs in the state. And also to promote different kinds of schemes to support the women entrepreneurs, like women entrepreneurial platform should be there, so that should be initiated from the government side. So these are my some of the recommendation that I have put forward for the policymakers. Thank you, sir.
Thank you.
Okay. Shall I wind up the presentation?
Yes, ma'am. Thank you, ma'am. Thank you, sir. We'll be proceeding on with our next paper presenter. I'd like to call upon paper presenter Vineet Wag with the paper title Face Recognition Based Attendance System FRAS. Sir, if you're ready, then you may start ahead.
Yes, just
Yeah.
Yeah.
is my screen visible?
Yes, sir, it is visible.
Okay. Good afternoon, everyone. My name is Vineet Wag. I'm from Vivekanand Education Society's Institute of Technology, Mumbai. And today I'll be presenting a paper, Face Recognition Based Attendance System, or, or FRAS. In any educational institute, managing attendance is a critical but often tedious task. Our project aims to modernize this process, making it faster, more accurate, and completely contactless. Over the next 10 minutes, we'll walk through the core problem. We are addressing our innovative solution, the technology that powers it, our testing results, and finally, the conclusion and future scope of the project. So, why is the new attendance system needed? Traditional methods have significant drawbacks. Manual roll calls are time consuming and prone to human error. Biometric systems, while being more accurate, require physical contact and can be unhygienic, and they are often struggle to scale in large institutions. This creates a need for smarter automated solution. So we asked ourselves, can we make an attendance automated, accurate, and invisible to our users? That's where the facial recognition comes in. It is non-intrusive, fast, reliable, and can be integrated with existing CCTV cameras without a new hardware cost. In our research, we surveyed existing systems. Earlier solutions used classical methods, machine learning like HOG, LPB, and PCA. More recent work has shifted to deep learning with CNN for better reliability. Some have even explored unique hardware like fisheye lenses. However, we identified a gap. The need for a system that combines the state-of-the-art accuracy with practicality of using existing infrastructure. And that is exactly where FRAS comes in. Our solution FRAS is comprehensive system designed to automate attendance seamlessly. Here's how it works. First, it captures a live footage from the camera. Then the system uses the powerful retina face model to detect the faces in the video. Then the face recognition library estimates who the person is by matching them against a database. Their faces are encoded and around 128 dimensional vectors are mapped and they are matched with the existing database. Then the attendance is automatically logged into the CSV file and the duplicates are removed. And finally, we have built a simple web interface, as you can see here, that allows the administrator to start or stop the attendance and download the reports. This means that there is no manual effort and no contact for the room of fraud. To build this, we used open source technology stack. The entire system was built on Python. We used Retina Face for high accuracy face detection mode. We use Retina Face because it is more robust in real world conditions compared to other methods like HOG or PCA, especially under varying light and angles. The face recognition library handles the identification. OpenCV is the backbone for all video processing tasks, especially for handling the RTSP, that is a real-time stream protocol from CCTV cameras. Flask powers the web interface, and Pandas is used for cleaning and managing the final attendance log. And this is how this system architecture is. The process starts with the input layer, where we take the live CCTV feed from the camera. Then the pre-processing module frames are extracted and resized. The core logic then begins. The retina face first detects the faces in the frames, and then the face recognition model encodes all those faces and matches them against our database. Recognized individuals are logged into the CSV, and user can control the entire process through a web interface which forms out the output layer. The requirements are Python 3.8, and the CCTV camera should have it should be IP camera, and it should support RTSP protocol. Another feature I would say is that the more the system is advanced, the GPU is advanced, the more fast it would work. It is directly proportional to the faster system. The testing. We conducted 3 rounds of tests to validate our system. The first test was simulated in the lab with 10 people. We achieved around 90% accuracy, confirming the core functionality worked even in smaller groups. The test 2 was in real university lab using a standard fingers 1080p high resolution camera webcam, which due to the webcam's limited range, the accuracy was around 80%. This was the key finding that pushed us to the next step. Our final test addressed this. We integrated a proper CCTV camera using the RTSP protocol and tested it in a live classroom with around 40-50 people, and the accuracy, the system successfully recognized faces at various angles and distances, achieving an accuracy of approximately 97%. These are, as you can see from the results, the system performs in different scenarios. On the left, you can clearly see the results from test 1, test 2, and the bottom, the results of test 3. And in the bottom right, you can see that faces are being scanned with multiple angles. So the more number of angles are being stored, the better the accuracy will be. So what is the key benefit of this system? It is completely contactless and hygienic. It provides real-time attendance data. It is highly cost-effective because it leverages existing CCTV infrastructure and it is scalable for large numbers of students. Ultimately, it improves efficiency, accuracy, and security while eliminating proxy attendance. So the system is practical today and not just theoretical. And since it runs on lightweight infrastructure, it can be easily scaled to multiple classrooms or even campuses. What's next? The project serves as strong foundation, and we have several existing directions for the future work. We plan to build this out as a full SaaS application, integrate cloud-based processing for even greater scalability, and features like student analytic dashboard. Crucially, we also plan to add mask recognition to ensure that the system remains effective in all conditions. This will make FRAS a foundation for smart campus automation. In conclusion, we have successfully developed FRAS, a functional and automated attendance system. It is practical and scalable solution that achieves accuracy in live classroom environments by integrating it with existing CCTV cameras. While it is currently a successful proof of concept, it is still under active development. Our work demonstrates that by combining robust technology like retina face with smart design, we can create a modern, reliable, and efficient solution for education institutes. Thank you for your attention. That's my time.
Okay, Mr. Vinit, tell me what is the difference between Face ID and face recognition?
Face ID and sorry.
Face recognition.
Face ID will be like allotted to the each person, and face recognition is detecting the face of the person.
Hmm. Okay. What is the fastest face recognition model?
As of now, as deep learning and CNN models are being optimized, there are many models, but as of now, we have seen that retina face can detect quicker than existing hog models.
Okay, thank you.
Yes, thank you.
Thank you, sir. We will be proceeding on with our next paper presenter. I'd like to call upon paper presenter Madhumati Shinde with the paper titled Fed Cloud, a Dynamic Trust Management Framework for Federated Environments. Ma'am, if you're ready, then you may start with the presentation. Ma'am, Madhumati? It seems we do not have her in the meeting yet. So we'll be proceeding with the next paper presenter, Ajuram P. with the paper titled Multi-LLM Framework with Dynamic Prompting. Sir, if you're ready, then you may start with the presentation.
Yeah, please.
Yeah.
Ajuram.
It seems sir has disconnected because of some network issue. While we wait for him, we'll proceed with the next paper presenter.
Next paper presenter.
Yeah, Aishwarya Nayak with the paper titled Real-Time Oversteering Detection of Vehicle Using Machine Learning and Embedded System Integration. Ma'am, if you're ready, then you may start with the presentation.
Yes, ma'am.
Yeah.
Ma'am, can you see my screen?
Yes, ma'am, it is visible.
Okay. Good afternoon, everyone. Myself, Aishara Nayak. I am in fourth year engineering from electronics and communication background. from Kere Technological University, Hubballi. So today I will be today I'll be presenting the paper titled Real-Time Oversteering Detection of Vehicle using Machine Learning and Embedded System Integration. Our paper ID is 1038 under the guidance of our Professor Supriya K. And these are my teammates which I worked with. And we will be going through a few of the contents, the problem statement, objectives, why this project is important, and functional block diagram methodology, and the embedded systems that we used in our project. So basically, let me start with what is oversteering. Oversteering is when a vehicle turns more than driver's intents, often due to the rear wheel turning faster than the front wheel. This can cause the vehicle to lose control and it may spin out. And this is the visual representation, as you can see, as the vehicle is turning more than intended and it is spinning out of the road, which may lead to fatal accidents, and the driver and the passengers may lose their life. So our problem statement is to develop an efficient oversteering detection system that can accurately identify oversteering conditions in real time using real-time data from the sensors, that is the IMS sensors that we used, show indication on detection of oversteering, and thus reducing the risk of road fatalities and injuries. So the objectives of our project was to understand the vehicle dynamics and the different steering conditions, and also how the different climatic conditions will affect the steering, affect the vehicle, and to analyze and to collect the data for various steering condition of the vehicle, and to develop an oversteering detection system based on the generated data set. We generated our own data set with the help of our from the club in our college. So basically, why this is important? This is important because from the reports from Ministry of Road Transport and Highways in 2022, there were about 4.61 lakh road accidents in India, resulting in 1.68 lakh deaths and 4.43 lakh injuries. So what leads to this accidents was that the 77.3% of all the accidents was due to the loss of the control of the vehicle and the error in the driver side. So uh, if we look into this, the most of the accidents took place while they were turning while they were turning at the corner of the roads or at the high speed. That's when the oversteering comes into picture. So this is the functional block diagram, as you can see on the screen. First is, as we didn't get much of the data set that we required for our project. So this is the data collection. So first we collected the data collection. Then we labeled the data as 1 or 0. That is 1 for oversteering condition and for 0 for normal conditions of the vehicle. Then we trained the model using decision tree algorithm. Then the data set during the training, the data set was split into 80:20 ratio of the total of the data set, and the model was trained. And then later on for the evaluation, then for model testing and evaluation, and later on we detected whether the vehicle was oversteering or not by giving an input from the user as well. I'll show it to you through the next slides. So this is the methodology that I have discussed. The data collection, next is the binary labeling, model training, model testing, and hardware implementation. So the data collection, for the data collection, we use two embedded systems, that is Arduino Nano 33 BLE Sense and ESP32 integrated with MPU 6050. So this is the flow chart. The first is the data acquisition block. Based on the threshold comparison block, if the thresholds were exceeded, if it was an S, then based on the decision tree algorithm, we detected the oversteering, and for an indication to the driver, there was a blinking of the LED that the vehicle is oversteering right now. So this is the setup for the data generation. As you can see, this is the model. So this is the first is the Arduino Nano 33 BLE sense that is attached to the the steering angle of the vehicle, and MPU 6050 integrated with ESP32 was placed at the dashboard of the vehicle to calculate lateral acceleration, forward acceleration, and yaw rate of the vehicle. And through the to calculate the steering angle, we have connected the Arduino Nano 33 BLE sense to the steering of the vehicle. So this was set up done in our college with the help of the motorsports club, and based on the threshold, there was the threshold set up for all the three parameters, that is yaw rate from minus 0.5 to 0.5 radians per second, lateral acceleration from 5 to 5 meter per second square, and steering angle from minus 100 to 100 degrees. That is, if the if the steering angle is in the center, that from there to the left side, if it is, that is minus 100 degrees, and to the right side to the plus 100 degrees. Through that range, if the vehicle is in that range, then the vehicle is not oversteering, and if it is more than that range, then the vehicle is oversteered. So this is the embedded system that we used, Arduino Nano 33 BLE Sense. These are the specifications, and the main reason to use this is it has an integrated IMU sensor. It gives 9-axis motion sensor, that is the accelerometer, that is in X, Y, and Z direction, and gyroscope for X, Y, and Z, and magnetometer. So we used for Arduino and 33 BLE sense, we used for steering angle the gyroscope Z axis to get the steering angle from the vehicle. And this is the ESP32 with MPU 6050 integration. As you can see, the integrated circuit here. We used through I2C communication protocol, the data from the MPU 6050 is set into the ESP32, and the libraries that we used are the wire.h for I2C protocol, MPU 6050, Adafruit, that is MPU 6050, to collect the data. This is the now let us come to the training of the model. Now the data set is been collected and labeled. So we used a decision tree algorithm. As we know that the data set has been labeled as 0 and 1. Based on these conditions, the model is trained for 0 is like there are it is split into 2, that is for the 0 conditions, and the 1 condition node, that is a decision node. So if it is in a 0, then the vehicle is in normal condition, and if it is in 1, then it is in oversteering condition. That is how the model is trained. This is this model was trained using the Google Colab and Jupyter Notebook using Python language, and the oversteering system is implemented in Python, and we achieved an accuracy of 100% for the model training and testing. And as you can see it on the screen, that this is these are the values that were given as input for the testing as well, and the prediction was shown then and there. And the next is the hardware implementation. How we did it onto the hardware. This is the Arduino IDE setup, as you can see, and this is the hardware implementation. So basically, this is one which is on to the rightmost side. That is Arduino Nano 33 BLE sense that we used for the steering angle for the input. And next is and as you can see, there is an LED placed onto different boards, and this is to the leftmost side is ESP32 with integrated with MPU 6050 with the red LED being there. So based on the threshold values that I have said earlier, if the threshold values are greater, then it indicates that the vehicle is oversteered. So through this, the driver is indicated that there's a oversteering happening. So I'll show you an example video of how this really works. So are you able to see the video?
Yeah.
Yes. So as you can see, as the oversteering is shown in the screen, and parallelly the both of the sensors are working. So I would like to conclude by saying that oversteering detection plays a critical role, particularly in preventing road accidents caused by loss of control, especially in high speed or low traction condition, like in icy condition or in the rainy season. That's what we are seeing currently now. And hardware and software implementation is making it ideal for real-time detection of oversteering and indicating the driver so that the future accidents can be prevented, and life can be saved and reduce the fatalities. Thank you. If you have any questions, you can ask.
Yeah, Shwarya, tell me how you can calculate the accuracy?
Yes, sir.
how you can calculate the accuracy of your
Of the
model?
model. So we used F1 score and precision based calculation that shows that how many true positives and true negatives are available into the data set and to the and how is the model performing, whether it is giving all true positives or if there are any false positives as well.
And although there are so many research work is already done in this topic, so
Yes, sir.
what's new actually in your project?
Sir, actually, when we tried to find two research papers, they were the models which were on based on the machine learning models. But most of them, like no one did the work on the real-time detection using the embedded systems, and indication to the driver was not done. As we can see that oversteering, they have uh, and only one we could find was the BMW R&D, that is research and development. Only they did the oversteering detection using machine learning, sir. So keeping that reference, we wanted to extend to further using embedded systems so that it can give real-time detection.
What is the size of data set?
uh, so you're not audible.
What is the size of data set?
Data sets are around there are 8,000 data sets, like 8,000 points.
You are
If you want,
prepared manually.
I'll show
Prepare
it to you, sir.
manually?
If you
No. You are prepared manually, or have you visited to BMW head office or somewhere?
So we didn't get any, like we mailed them to get the data set, but we didn't get much of the response from there. So our professor suggested us to generate the data set, creating the conditions. So we took help of the motorsports club in our college, and we generated the data sets. As you can see, the setup in the presentation.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to call upon Sneha Temgire with the paper title Smart Irrigation System Using Raspberry Pi. Ma'am, if you're ready, then you may start with your presentation.
Yes. Is my screen is visible to you?
Yes, ma'am, it is visible.
Okay. So first of all, good afternoon, all of you. Myself, Sneha Sanjeev Temgire. I just completed my Master of Engineering from Savitribai Phule Pune University. So my paper title is Smart Irrigation System using Raspberry Pi. And my co-authors are Dr. Y.S. Angal, Ashwini Wagmare, Chetna Sharma, and Ashwini Gazre. They helped me a huge throughout this paper presentation. So these are the points I am going to explain through this presentation: introduction, motivation, problem statement, methodology, work implementation, summary, and discussion. Project irrigation system using Raspberry Pi. This project is a agriculture system which integrates AI-based plant disease detection, plant growth monitoring, and automated irrigation Raspberry Pi 3B plus model. This model. This project includes YL69 soil sensor for continuous soil monitoring, automated irrigation system controlled via relay and water pump, and Raspberry transmit real-time sensor data and plant health update to an HTML web page, allowing farmers and researchers to monitor crop conditions remotely through a web interface. This system integrates machine learning, computer vision, and IoT-driven automation to reduce manual effort, optimize water usage, and facilitate early disease detection. So the motivation behind choose this project is Agriculture plays a crucial role in food production, farmer, but farmers struggle with crop diseases, inefficient irrigation, and labor-intensive monitoring. Traditional methods rely on manual observation, which can be time-consuming, inaccurate, leading to delayed disease detection and improper water management. This paper is motivated by the need for smart agriculture system that detect plant disease earlier stage, plant growth monitoring, and optimize the manual and automated irrigation. By using Raspberry Pi, AI-based image processing and animation, the system reduces time, prevents water, ensure healthier crop. The addition of web-based monitoring interface plants accessible, allowing farmers to track plant health and irrigation simply. Hello.
Yes, ma'am.
Well,
Yes, ma'am, you're audible.
Yes. So objective of my projects are to detect diseases early using image processing and deep learning model deployed on Raspberry Pi. To monitor plant growth over time by analyzing images captured through the Raspberry Pi camera. To measure soil moisture level using IL-16 sensor and optimize irrigation based on real-time data. To audit the water supply system using a relay control water motor, preventing overwatering and underwatering, to enable remote monitoring and health and irrigation status through a web-based interface, to create cost-effective, scalable, and efficient system that improves the precision farming and reduces manual intervention. So the problem statement for this paper is traditional irrigation methods often lead to excessive water consumption, inefficient water usage, and increased operational cost. Farmers and gardeners face challenges in optimizing water distribution, especially in regions experiencing water scarcity or unpredictable weather conditions. A smart irrigation system using Raspberry Pi aims to address this issue by automating the irrigation process based on the real-time soil moisture level, weather condition, and predefined parameters. The system will use a sensor to collect data and determine the precise water requirements of crops. The Raspberry Pi will process this data and control water flow using solenoid valve, ensuring that plant receives adequate water without uh, wastage. So this is the block model as a main controller and hosting device. Already the OS version installed in the memory card. This is the power cable to turn on the Raspberry Pi. The Pi camera, which is used to detect the diseases and growth monitoring. The soil moisture sensor YL69, which is used to measure the moisture of soil. Water pump, and the water pump is used in this project. So because 5 first one is eye camera, which is the input to detect plant image. Second one is relay, which is output to drive motor, and last one is potentiometer, which is soil moisture input. So this is the overall setup of project. The first part of project is image processing for the disease detection. For disease detection of plant, I used the potato plant. This project is in its prima phase, so that's why I only perform the operations on potato plant. The Pi camera is used for capturing the image. The Pi camera is processed using OpenCV and TensorFlow Lite to classify plant disease. For plant disease detection, the system employs a CNN, a deep learning technique designed for image classification. The CNN model analyzes images captured by the Pi camera, identifying whether plant is healthy or diseased. The model is successfully classified healthy and disease plant based on the visual features like color, variations, texture, and leaf damage. The captured image is then compared with the standard datasets using convolutional neural network, gives the accurate prediction about disease detection and plant solution. So this image is the result of image processing for disease detection. Here it shows the disease of potato late blight, and here is the disease solution. Use copper sprays, remove infected plant immediately. If potato is healthy in that particular type potato disease, it shows that potato is healthy, and in disease solution it shows there is no action required. Next part is plant health monitoring. The Raspberry Pi camera module captures the real-time picture and picture of plant and transmits to the Raspberry Pi 3B Plus model for performing analysis like it shows the how much growth percentage of that particular plant is here it shows the plant growth 81.38%. It is showing on the green part of plant. So we can see with our own eyes that the smaller plant is shown to smaller and the larger plant is shown to higher growth percentage. This understanding comes to us without any technology, but this technology is used for those who living in cities. They are unable to visit their farms on a regular basis, so they can monitor using Pi camera. This helps ensure that they don't suffer any losses in farming. The last part is soil moisture detection and automated irrigation. So for moisture detection and automated irrigation, I used soil moisture sensor YL69. The soil moisture sensor works on the principle that wet soil conducts better electricity than dry soil. The YL69 soil moisture sensor is connected to YL38 module, which converts analog signal into digital output for easy integration. The sensor data provides real-time soil moisture data, which is used to automate irrigation by activating a relay control water pump when the soil moisture level falls below said threshold. The water pump is controlled by a relay module. So the relay module is an electronic switching device that allows low power microcontrollers such like Raspberry Pi to control high power electrical components like motor, pumps, etc. It acts as a bridge between the low voltage control circuit and high voltage devices, ensuring safe and efficient switching without direct electrical contact. The relay module used in my project is 5-volt single channel relay that is triggered by the GPIO pins. These are the results of automated irrigation. I can perform this action using manually also. If soil moisture sensor detects soil is dry, then the water pump automatically turn on. And if soil moisture sensor detects soil is moist, then water pump automatically turn off. That's it. So this is the summary of my project. This project demonstrates the integrated system, which is mainly focused on automated and manual irrigation. In addition, with the irrigation, we can also measure the growth of plant disease and disease detection of potato plant using Raspberry Pi camera. With technology advancements in image processing, the output of all parameters seen on the HTML web page. So these are the advantages of project. Automated plant disease detection. The integration of Raspberry Pi and CNN-based deep learning technique allows for accurate and reliable plant disease identification. The system analyzes plant images, detecting disease earlier and helping farmers take timely preventive measures to reduce crop losses. real-time monitoring and irrigation control. Our system continuously monitors soil moisture level and plant health in real time. By automating the irrigation process based on live sensor, the system ensures that receives the right amount of water at the right time, improving water efficiency and manual effort. Objective and consistent result. By leveraging CNN and IoT-based sensor, the project eliminates human errors in plant assessment. The data-driven approach provide consistent and accurate clarification, ensuring that farmers receive reliable insight for better decision making, cost-effective precision farming solution. Our project uses affordable components such as Raspberry Pi soil moisture sensor, relay control water pump, making it low cost and scalable solution for smart agriculture. This affordability can ensure that small scale farmers can implement precision farming technologies without significant financial investment. So the disadvantages for uh, project is high initial cost. Sometimes the system can expensive and purchase to install advanced systems like sensor controllers integration uh, with other smart devices often come with a higher upfront cost. The other disadvantages is dependency on technology and power. The system rely on continuous power and internet connection for data transfer and control. In areas with the unreliable internet of power outage, the system may not function optimally or at all, leading to irrigation issues, complexity and of installation and maintenance. Installing smart irrigation system often requires technical knowledge, especially when integrating with sensor controllers and mobile application. Moreover, maintaining these systems may require technical skills which can increase the dependency on service provider or technicians. Vulnerability to technical failures, like in technology, smart irrigation system are prone to malfunctioning in sensors, controllers, or software. This could lead to incorrect irrigation timing or volume, potentially harming crops or landscapes. Data privacy and security risks, since many smart irrigation systems connect to the internet, they may pose a risk of data breaches or hacking. Data without the water wastage, location, and other sensitive information could be vulnerable if not properly protected. These are few applications of smart irrigation system. Agriculture. Smart irrigation helps farmer monitor soil moisture, temperature, and crop water wherever if needed. This leads to optimized water usage, preventing overwatering and underwatering. Landscape management. We can use it for residential use also, like home lawns and gardens, green roofs and vertical gardens. Water resource, another one is water resource management and conservation in municipal water corporate conservation, uh, sport facilities, sport field and stadiums, greenhouse management, and research and development, like agri-tech innovations. Research facilities use smart agriculture irrigation to study water use efficiently, crop growth patterns, efforts of various water levels of plant. Thank you.
Sneha, what are the biggest challenges in a smart irrigation system?
Sorry, sir, you are not audible.
What are the biggest challenge in a smart irrigation system?
Mm, Actually, every system में वो इसके प्रॉपर के लिए नेटवर्क करने में थोड़ा प्रॉब्लम.
चलो, okay, thank you.
Yes, sir, thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to call upon Souvik Bose with the paper titled Sustainability of Avian Monitoring Near Mobile Base Stations Using Drones, a case study in Arambagh Municipality, Hooghly, West Bengal, and India. So if you're ready, then you may start with your presentation.
Yes. I am audible?
Yes, sir, you're audible.
Okay. 1 minute. Is my screen visible?
Yes, sir, it is visible.
Okay, thank you. Okay. Good afternoon, everyone. I am Souvik Bose from JS University, Kolkata. Today, I will be presenting a case study focused on using drone technology for sustainable event monitoring near mobile-based station in the Arambagh municipality, Hooghly district of West Bengal, India. This research aims to understand how increasing mobile tower installation may be affecting local bird population and their behavior. Avian monitoring is critical for biodiversity conservation. Bird serves a key bio indicator of environmental health. They keep track changes in habitat, climate stressors, and pollution effects. However, the rapid expansion of mobile telephony has introduced a new environmental variable, that is electromagnetic radiation, EMR. The EMR may interfere with avian behavior, navigation, and reproduction system, and makes this a grow concern. Our study was conducted in Arambagh municipality, Hooghly district of West Bengal, India, located at 22.88 degree north and 87.87 degree east. This is a semi-urban area known for its rich avian diversity. But in the past few decades, it has seen a sharp rise in mobile-based station installation. This made it a suitable location to study how birds respond to EMR in such challenging environments. Studies suggest EMR may cause a range of problems for birds. Disruption in navigation, particularly in migratory birds, changes in reproductive patterns, abandonment of nesting near mobile towers, reduce of communication and feeding efficiency, increased stress levels. This study aims to capture and analyze such behavioral and ecological response in real world context. We had three primary objectives. Number one, compare the occurrence and diversity of birds near and far from mobile towers. Number two, examine behavioral changes like altered nesting or flight patterns. And number three, test the effectiveness of drone assist monitoring over the traditional methods. Initial survey was done using binocular DSLR cameras and field observation. We also include local reports and ornithological records also. We used a DJI mapping mini drones for aerial surveys. Each flight lasted around 20 to 30 minutes and covered selected tower sites. We captured high resolution images and videos while ensuring minimal disturbance to wildlife. Drone monitoring allows us to gather continuous and non-intrusive data over wide range. Flight followed grid pattern to ensure complete coverage. At 30 to 50 meters, we focused on nesting and rotting on trees, trunks, and buildings. At 80 to 100 meters, we observed general movement and population density. And above 100 meters, we monitored long distance flights, path, and navigation. Observations were made at three different times: early morning, noon, and evening, to capture behavior across the day. Compared to the traditional method, drones offer several advantages. Number one, non-invasive and efficient. Number two, high resolution and real-time data. Number three, ability to cover restricted or difficult terrains. Number three, reduce field time on manpower. Furthermore, drone data can be combined with machine learning tools in future to automate species identification and behavioral analysis. We also measure radiation intensity using MECO in 9720 electrosmog. This was done at varying distance from base station. This allowed us to correlate observed bird behavior with radiation exposed intensity, offering a more evidence-based analysis. Several interesting behavioral patterns emerged. Many small birds avoiding flying directly over the towers. Nesting location were shifted away from the high EMR zones. Large birds like crow, pigeon showed more tolerance, still rotting near towers. This suggests species-specific sensitivities to EMR. We also observed behavioral disruption. Less foraging activity was seen near towers. Flocking patterns become more scattered and less coordinated. Local communication was reduced in some species, potentially affecting mating and coordination. These subtle changes can lead to long-term ecological imbalance. This graph shows how power density drops with increasing distance from the mobile tower. It visually reports our observation that birds shows more natural behavior at lower radiation zone. Here is the summary of drone recorded data. It shows species count and frequency near various base station. That trend clearly indicates reduced avian presence in area with higher radiation exposure. To conclude, there is a clear impact of EMR on avian species, behavioral, social, and ecological. Drone assist monitoring provides to be a sustainable, scalable, and non-invasive invasive tools. Policymakers must consider the ecological cost of unchecked power tower installation. Further development of drone technology and integration with AI could revolutionary environmental monitoring. And I like to thanks to JS University, Agarpara, Arambang Municipality, and local residents who support us throughout this study. And this collaboration was crucial in fieldwork, access, and observation. And these are the references we used before going to the fieldwork. Thank you.
Okay, so tell me, what is the during implementation of this project, which is the biggest problem you have faced? Difficult
Uh,
handled.
Difficult task actually, sir. The difficult task is that the local people local people of that area where I did the survey or the study, they first very much curious to know what I doing. I am using drones and what actually we did 3 times a day, and the survey is conducted 3 times a day, early morning, noon, and afternoon. Every time when I go to that place, and the local people is very curious to know what is that doing. That's the first thing I faced to that field work, and after that they are cooperative, and that's the biggest challenge I think I faced.
Suppose if I want to purchase your product, so what is the
Sorry,
cost?
sorry.
Suppose if I want to purchase your product, okay. So what is the cost?
Sir, actually that we haven't built any product to uh, use to monitoring the parts actually. Okay, so this is my one of my research work. Okay, so in this research work we use drone. Okay, so actually this is a field survey based research work. Okay, there is no instrument, a particular instrument you can buy and do that work. It is not possible.
What are the limitations?
Sorry.
What are the main different limitations?
So limitation means limitation is there is some limitation because when I use that drone, there is a noise from the popular of the drone. That's what the biggest noise of the drone can
मेरे
be
काम
the
आहे.
biggest. Sorry.
बरं नाही बसा ना हे
Sorry.
मुलं येत आहेत. Okay, thank you. Yeah. Thank you, Sumit.
Thank you,
Thank you.
sir. We'll be proceeding on with our next paper presenter. I'd like to call upon paper presenter Dhanashree with a paper titled The Chain Reaction: How Cliffhangers and Binge Watching Lead to Self-Regulatory Depletion, Binge Eating, and Impact Mental Well-Being. Ma'am, if you're ready, then you may start your presentation. Dhanashree, ma'am?
Yeah, am I audible right now?
Yes, ma'am, you're audible.
Yes, thank you so much. So, good afternoon, everyone. And my name is Tanyashri, and I'll be presenting our study today, the chain reaction on how cliffhangers and binge watching lead to self-regulatory depletion, binge eating, and impact of mental well-being. The research is being conducted with my collaborators from Amrita School of Business, exposing how streaming platforms design choice trigger a psychological domino effect. So I'll walk through, and so this is what we are going to look into, and we'll start with why to explore this chain reaction. So as a Gen Z researcher, I noticed two things. First is my own watching habits that kept me hooked until late night, and the second is my peers binge watching significantly more than the older generations. So this isn't accidental actually. The streaming platforms deliberately use cliffhangers to pair with the autoplay features and automate them to binge watch. So together they override the viewer's conscience and intend to stop, normalize binge watching, and that is actually viewing more than three or more episodes at one sitting. The motivation of our study. So why this plot is our goal is we had three research goals. First one is to examine what cliffhanger has catalyst for binge watching. The second is investigating the self-regulatory depletion. And third, how depletion enables impulse behavior like binge eating and ultimately harming the mental health. So the research gap on why we focus here is the existing research overlooked these critical gaps. While prior works link binge watching to sedentary risks, psychological cascade via self-regulatory depletion theory remain unexplored. The study also treats viewers as homogeneous, ignoring the traits like self-control that buffer harm. Most critically, the media role in triggering impulse eating is unstudied. So our work bridges these gaps. Let's look into our conceptual model. Our model has cliffhangers, binge watching, self-regulatory depletion, binge eating, and mental well-being. So the cliffhangers is manipulated curiosity through unsolved suspense. Binge watching means watching more than three episodes in one sitting, that is, watching for more than 3 hours. Self-regulatory depletion is exhaustion of finite willpower resource impairing decisions. Binge eating manifests as impulse overeating post-viewing. Mental well-being is measured via the validated well-being scale. The sequence explains how platform mechanisms exploit human psychology. The methodology that we used, how did we test this? We deployed a cross-sectional survey of 170 Indian streaming users aged between 18 to 45, stratifying by age and gender. Our sample included Gen Z, millennials, Gen X, and boomers, with all these percentage mentioned. We use a psychometric rebus scale detailed in this table. Let me walk through that. The table lists 5 constructs, their measuring scales, and Cronbach alpha for the reliability. Starting with cliffhangers, we have Vanden Bratt of scale 0.92. For binge watching, we have binge watching engagement scale of alpha 0.95. Self-regulatory depletion was measured by a briefing self-control scale of alpha 0.93. Binge eating scale of 0.87, and finally the mental well-being scale of 0.889, confirming a high internal consistency, meaning these tools are reliable to capture the reality. What did we find? So before revealing the chain, let's highlight who affected the most. The descriptive data showed a stark generation divides. Gen Z watched 4.2 hours daily, far exceeding the millennials of 3.1 hours and Gen X 2.7 hours. They also reported that the highest self-regulatory depletion. Gender difference emerged too. The women displayed stronger binge eating tendency of average score 3.1 versus men 2.6. This gap was statistically signified and aligned with prior work linking emotional eating to stress. Following with the result, let me break down our key findings into a simple but powerful way. The numbers tell a clear story but about how this chain reaction works. First, the cliffhanger are like a psychological bait. Our data shows that they have a massive 0.6 impact on binge watching. That is a huge in research terms. When people encounter cliffhanger, they are 65% more likely to depend watching episodes after episodes. Now, all that binge watching comes at a cost. It drains people's willpower about 40%. Think of it like a mental battery running down. When that happens, people become 5% more likely to binge eat. That is not a huge jump, but still not noticeable. Here's where it gets concerning. The binge eating then drags down mental well being by nearly 45%. That is like going from feeling pretty good to just okay, a meaningful drop in life satisfaction. What's really interesting is how much each of these P's explains. The cliffhangers explain about 25% why people binge watch. Binge watching explains why 35% of willpower drain. But willpower drain only explains about 2% of binge eating, meaning other factors are also in the play. Yet another, this chain also explained that 11% of well-being changes, which significantly in psychological research. So in simple terms, cliffhanger traps us into watching more, which tries out and makes us snack more, ultimately leaving us feeling worse. These numbers prove us what many have felt, that just one more episode have it as real consequences. So what does this mean? The cliffhanger are behavioral weapons. The effect on binge watching exposes how platform hijack curiosity. Second, the Gen Z and the women are in the crisis zone. Gen Z's 4.2 average hour of viewing and women's binge eating 3.1 reflects acute vulnerability. Third, the platform engineering addiction. As a paper states, cliffhanger and autoplay exploits cognitive vulnerabilities, outsourcing self-regulatory to algorithms. Even weak links like depletion in binge eating matters because the compound is over time. Crucially, self-regulatory depletion explains only 2.3% of binge eating variants, inviting future works on strong mediators. So there comes our unresolved mysteries. We acknowledge constraints. First, the cross-sectional data captures a snapshot. It can show how binge watching spirals weekly. Second, cultural bias. Our Indian sample may not generalize into individual societies. Third, the self-reported binge eating risks underreported due to shame. Number four, unexplored moderators like self-efficiency could be an alternate vulnerability. Future studies should longitude design across the cultures and measure the traits like media literacy. And to conclude in closing, cliffhangers plus autoplay has a proven well-being threat. This chain binge watching depletion, binge eating, impulse eating, and reduced well-being is a disoperating impacts Gen Z and women. This isn't just science. This is ethically imperative. Platforms must redesign features. Simple interventions like autoplay disability buttons or viewing limits could protect millions. Our call, prioritizing human psychology over engagement metrics. Thank you, and I thank ICT4SD team for making this research a blockbuster possible for me as well.
Okay, let's see. What is the another word for binge watching?
What is another word for binge watching?
Hmm?
Um, It is actually continuously watching for hours, sitting in one place actually. So if you want another word, I actually don't know, but the meaning of binge watching is actually If you sit for around 4 or 5 hours continuously watching episodes after episodes, then I would call that it is a binge watching.
Okay, which stream is better than Netflix?
There is nothing called a better stream than Netflix, because each and every place there is an autoplay option where you pop up a next episode button in every platform, not only Netflix, even in Prime, even in Hotstar, and there are many platforms like this actually. So everyone do this because they want people to hang in into their platform.
Thank you.
Yeah, thank you so much.
Thank you, ma'am. Thank you, sir. I'd once again like to ask for our previous presenters, Ma'am Madhumati Shinde, or anyone who is going to present on our behalf, if you're here,
So how
or
many
sir,
remain?
uh, uh, sorry, sir.
How many presenters are remaining?
Sir, two presenters haven't presented. I'll just ask for them, and if they're not in the meeting, then we'll proceed with the closing remarks.
Please.
Yeah. Sir Ajaram, if you're here to present your paper, you can start. It seems we do not have the presenters, so that brings us to our closing remarks. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. Just before we end the session, I'd also like to thank our session chair for chairing the session. A token to the chair on behalf of team ICT4SD and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you very much.
Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Thank you.